In our previous video, we have seen the zero adjustment. Now we will try to analyze the purpose of the span adjustment pot. So we would prefer to have a temperature display with respect to the resistance of the RTD as a linear relationship. We can recall that the RTD itself is a linear sensor, and so in our previous video we showed that if the resistance of the RTD is 0.1 kilo ohm, then the temperature display should be 0. Now we would like to work towards the other point in this straight line. So you see that in this particular operational amplifier, the node V2 gets connected to Vin, the input plus terminal of ICL 7107, and the output V2 can be written as negative of 100 by Y multiplied by V1, where Y is the resistance coming out of this potentiometer, which will act as the span adjustment pot. And we can proceed and say that V2 can be written as K times V1, where K is the gain. More preferably we would use the term closed loop gain, and this is the same as Vin. And then we remember from our previous video that Vx should be equal to 1 by 1 plus RTD. So come to this circuit once again, and we have fixed the value of X now. This is possible because we have done the zero adjustment right at the beginning, and we can walk through and analyze this particular circuit and try to obtain an expression for V1. So as before, we apply nodal method over on this network, and we can frame the equation as Vx minus V divided by 0.5239 plus minus V minus 1V minus of V divided by 0.4761, which equals to this current, which is given by V divided by 100. And we can do the little algebra, and we obtain an expression in terms of V with respect to Vx. Again, because this is an inverting adder, we can easily frame V1 as negative of V RTD, and V RTD is equal to 1 minus Vx. So going back to this equation and substituting the value of V and V RTD, we come to this equation. And then finally we make another substitution where Vx is 1 by 1 plus RTD in this equation over here, and then get the expression for V1. So the display temperature T is 1000 times Vin by Vref, and we can substitute the value for Vin, and we also know that Vref is 1 by 1 plus RTD, and from here we obtain the relation between the display temperature and the RTD resistance. And you will observe that this is a linear relationship. It's of the form Y is equal to mx plus c. And you will also find that if we substitute RTD with 0.1 K, that means we are looking or trying to note down the value of temperature when the RTD resistance is 0.1 K, then we will find that this number comes out to be very close to 0. So our zero adjustment was perfect. And then as an example, if you remember from the experiment, we had a temperature value of 60 degrees centigrade which was observed from the thermometer, and the RTD resistance was showing as 0.1 to 1 K. So substituting those values, we can find out the value of Y, which is 16.81 K. So you can vary the span adjustment pot, setting it to 16.81 K in order to satisfy the calibration for this particular experiment.